Buckle up and prepare for a front row seat to one of the most epic celestial spectacles ever witnessed by astronomers. Get ready to witness the cosmic battle of the ages as a monstrous black hole unleashes its gravitational might, tearing apart a hapless star in a display of raw celestial power. Join us as we delve into the mind-bending world of black holes and unveil the jaw-dropping footage captured by astronomers as they witness this extraordinary event. Brace yourself for an adrenaline-pumping journey through the cosmos that will leave you in awe of the sheer force and beauty of the universe. What happens when a star wanders too close to a supermassive black hole? The obvious story is that it gets sucked in, never to be seen again. Some of its material gets superheated on the way in, and that gives off huge amounts of radiation, usually X-rays. That's not a wrong explanation, just incomplete. A black hole. There's more to the story, thanks to a team of astronomers at the University of California at Berkeley. They used a specialized spectrograph at Lick Observatory to study a tidal disruption event. That's where a star encountered a black hole. What they found was surprising. Watching a doomed star swirl away. Supermassive black holes are found in galaxies throughout the universe. When a star wanders close to one, strange things happen. The gravitational pull rips the star apart and stretches some of its material in a process called spaghettification. Recent studies of tidal disruption events suggest that other things happen too. For example, intense winds flowing outward from the event send some of the doomed star's material out to space. It's all part of its weirdness. One of the craziest things a supermassive black hole can do is to shred a star by its enormous tidal forces, said team member Wenbin Liu, UC Berkeley Assistant Professor of Astronomy. Stellar tidal disruptions. These stellar tidal disruption events are one of the very few ways astronomers know the existence of supermassive black holes at the centers of galaxies and measure their properties. However, due to the extreme computational cost in numerically simulating such events, astronomers still do not understand the complicated processes after a tidal disruption. That's why studying an actual star as it meets its doom is so important. The Berkeley group zeroed in on one that got too close to a black hole in an event called at 2019 KISS. The disaster occurred some 215 million light-years away from Earth in a spiral galaxy in the constellation Eridanus. As the star spiraled into the accretion disk, it got shredded. Then something wonderfully unexpected happened, and it took some special effort to see it. A polarized view of the action. Since the disruption event looked quite bright in optical light, the team members decided to study it in polarized light to get a better sense of what was happening. Polarized light waves travel in a single plane, and that reduces the intensity of the light. This is the same principle that polarized sunglasses use to reduce glare. In this case, using polarized light allowed the team to see the aftermath of the star being shredded. Usually, they don't get to see that. Based on observations of other similar events, they also didn't see the expected amounts of X-rays. So, what was going on? For at 2019 KISS, the spectropolarimetry observations revealed that much of the star's material never made it into the black hole's hungry maw. Some got smeared across space. However, the intense winds from the black hole also created a spherically symmetrical, high-speed cloud of leftover stellar material. The team clocked it rushing out at about 10,000 kilometers per second. That cloud provided some surprises. A shredded star supplies clues to similar events. This unique look at the disruption of a star explains why astronomers haven't seen large amounts of high-energy X-rays from this and other similar tidal disruption events. The strong winds created the cloud, and the cloud is blocking much of the high-energy radiation from the disruption. People have been seeing other evidence of wind coming out of these events, said Koshor Patra, a graduate student and lead author of the study. I think this polarization study makes that evidence stronger, in the sense that you wouldn't get a spherical geometry without having a sufficient amount of wind. The interesting fact here is that a significant fraction of the material in the star that is spiraling inward doesn't eventually fall into the black hole. It's blown away from the black hole. What's next? Using polarized light provides an important tool for studying what happens when other stars encounter supermassive black holes. It also gives astronomers access to events in the accretion disk of the black hole. It's not an easy task. These disruption events are so far away that you can't resolve them, so you can't study the geometry of the event or the structure of these explosions, Filipenko pointed out. But studying polarized light helps us to deduce some information about the distribution of the matter in that explosion, or, in this case, how the gas, and possibly the accretion disk, around this black hole is shaped. Polarized light from these types of bright eruptions is a valuable tool to map these events. Ultimately, such observations could help build a tomographic picture of a tidal disruption event as it evolves, even if it's in a galaxy far, far away. As we reach the thrilling conclusion of this mind-bending journey, witnessing the awe-inspiring spectacle of a black hole tearing apart a hapless star, we are left humbled by the raw power and immense forces at play in our universe. This cosmic ballet of destruction and creation serves as a stark reminder of the extraordinary phenomena that unfold in the darkest corners of space. Astronomers have granted us a front-row seat to this cosmic spectacle, expanding our understanding of black holes and their insatiable appetites. This captivating event underscores the profound mysteries that continue to elude us, urging us to delve deeper into the enigmatic realms of our cosmos. So let this mesmerizing encounter fuel your curiosity and propel your imagination to new heights. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.